In this video, we'll talk about transformations of functions. And first of all, let's introduce the notion of parent function. So a parent function is the generic one. Like, for example, the linear functions would be f of x equals x. F of x equals x squared is the quadratic one. X cubed is the cubic function, square root of x, maybe cube root of x, absolute value of x, and then when you go to trigonometry, you'll see sine of x, cosine of x, all the trigonometric functions. Also, ln of x are parent functions. So what we're going to do, we're going to take a parent function, like in our case, let's discuss about f of x equals x squared. We'll take that as our parent function. So if I want to graph that, I can give three values. That would be the best, x and f of x. I'm going to put 0, 0, right? If x equals 0, f of 0 equals 0. Negative 1, which is going to produce 1, and 1, which is going to produce 1. So if I plot it here, I'm going to get this negative 1, 1, and 1, 1, and the origin. So when we graph it, we obtain this parabola. So this is the graph of f of x equals x squared. Now look what happens. We can have this type of transformation, f of x plus c. Like in our case, since we chose x squared to be our function, let's say we add a number, plus 1. What will happen to the original function that we got is going to shift entirely 1 unit up. So basically, our function, each of these points is going to shift up 1 unit. So this point here is going to become, let me choose a different color. Is going to become this point. This is going to go up 1. So it's going to be this point, and this is going to go up 1, this point. So the graph is going to be this one. So by keeping it this way, we actually show how it shifted 1 unit up. So if we are adding a value to the parent function, it's going to shift up. Now, if we are subtracting a value, it's going to shift down. So let's try the second one. So I'm going to again graph the x squared in black and the origin, and then 1, 1. And this is the parent function, the graph of the parent function. And then if I have the parent function minus 3, for example, what's going to happen? This graph is going to shift 3 units down. So this point, the origin is going to be 1, 2, 3. The new origin is going to be at negative 3. This point is going to shift down 1, 2, 3. My units are not that clear, but the graph is going to be the same, just shifted 3 units down. Now let's take a look at the third situation. What happens if the x of the function has added c units? So in other words, if I have x plus 4 squared, right? So our original function is x squared. What if you add to x and then you square it? Well, if we add, this is gonna shift 4 units to the left. So in our case, let's graph again x squared, because this way we can see easily how the shift is done. So this is the x squared. And for simple transformation, it's good to put all of them on the both of them on the same graph. And now let's take a look at the other one. So we shifted 4 units to the left. So 1, 2, 3, 4. So my graph is a little bit. So 4 units to the left. So this would be negative 5. And the other points are going to stay where they were. So the graph should be identical, only shifted 4 units to the left. So when it's a plus, we shift it to the left. Let's take a look at the next one. What if we have x minus 1 squared? So let's grab the original one. Let's grab the x squared again. So negative 1, 1, 0, and 1, 1. This is the original x squared. And now x minus 1 means shifted 1 unit to the right. So 1 unit to the right, this would be the new origin. And these all are shifted 1 unit to the right. This would be 2. So the new graph would be this one. Okay, let's take a look at the next one. F of negative x, it's reflect f of x about y-axis. So when we do f of negative x, we actually get negative x squared, which is x squared. So here we cannot see much because how do we shift it around y-axis? Well, it's already symmetrical. So for this one, let's try and do another function. Maybe it's going to be more clear. So I'm going to pick square root of x as the parent function. So square root of negative x would be the function that we are getting when we reflect it about y-axis. So let's see how that looks like. X. So I'm going to graph again x squared here. So negative 1, 1, 0, and 1, 1. So this is the x squared. And I want to see what happens to 1 over 2x squared. Well, 1 over 2x squared is going to be shrinking, right? So for negative a half is going to be, negative 1 is going to be negative a half. And for 1, it's a half, so it's going to be like this, a vertical shrinking. And the last one, f of cx. So basically, what's going to happen if we have for c equals 2, for example, then it's going to be 2x squared, right? So we multiply the function by the x by 2, so it's 4x squared. And what happens is it's 1 over 2, we're going to have 1 over 2x squared, which is actually, sorry, this is squared, which is 1 over 4x squared. So these ones, because they are pretty similar with what we had above, just imagine that while there is a vertical shrinking here, stretching, I mean, while it's a vertical stretching, it's a horizontal shrinking. While here, when it was a vertical shrinking, it's a horizontal stretching. It stretches on the x-axis more. Now, we can have problems where we have a combination of all these. So let's take a look at this example. We have f of x equals negative 2 times x plus 1 to the second minus 3. Well, when we have more than one transformation, there is an order of operation, like you have for, like you use PEMDAS, right, for numbers. The first one is we have to do the horizontal translation. Then we have to do the stretching or shrinking. Then we have to do reflection, and then we have to do vertical translation. So in our case, we have all of them. This is 1 unit to the left. This is stretching. This is reflection. And this is vertical translation. So this is step 1, step 2, step 3, and step 4. So what I'm going to do, I'm going to graph the parent function, and then I'm going to graph each individual transformation, and then I'm going to put them all together. So let's start. The parent function, obviously, here is x squared. So I'm going to graph x squared. -1, 1, 0, 0, 1, 1, and this is the parent function. Now the next one is the shifting 1 unit to the left. So this graph that we have here, we're going to shift it 1 unit to the left. So all these are going to shift 1 unit to the left. So basically it's going to be the new origin is going to be here, or vertex. At -2, 1 is going to be the next point. And at 0, 1 is going to be the next one. So this is actually x plus 1 squared. Then we have stretching with 2 units. So this graph that we had here is going to stretch, so here at -1, and then is going to stretch a bit, right? So it's not going to be as open as it was before. Now, so we're going to have these points at the -2 now is going to be 2, right? It's going to go all the way up to 2 instead of 1, right? Because it's stretched. Okay, now we have negative, so this graph that we just drew here, I'm going to reflect it. So -1, and then is going to reflect in the x-axis. So at -2 is going to be -2 here. And then we are going to shift it 3 units down. So the graph that we had, -1, is going to be 1, 2, 3. So it's going to start from here. So we went through all these steps. What I'm going to do is I'm actually going to draw on the original one that we started with. I'm going to draw this final answer, which is 1, 2, 3, -3 here at -1, and then it's going to go like this. And this would be what we've done to the graph to transform it. So f of x, here is the graph. Now let me show you how to do this using the calculator. So if we look at the calculator, if you go to y equals and you plot x to the second and you graph it, it's going to show you this graph, right? X squared. Now if we go y equals, so you can use the calculator just to check your answers. So what if we have x plus 1 to the second? So if we press them, actually keep the x squared just so that you see that what happened. The graph was shifted 1 unit to the left, which we would expect. Now let's take another one. Let me clear this and make it 4x to the second. So what's going to happen to the graph of x squared? Well, it's going to stretch along y-axis and is going to shrink along x-axis. Let's see another one. Let's see what happens if we have negative x squared. Well, it's going to reflect into the x-axis. So now let's make a combination of all these. Let's make -2 times x plus 2 to the second minus 3. Let's see what happens when we graph it. So we had our original function x squared, and then we have the function that was rotated, it shrunk, and it was shifted 2 units to the left. You can play with this with any kind of functions. You can do absolute value, you can do square root, for example, look, square root of x, and then square root of x minus 3. We would expect it to be shifted 3 units to the right, which is true. I hope this helps.